a sophomore at Brown University. Jacob, thanks so much for joining us.
Thanks for having me.
I'm super pumped to talk about this. So Jacob is a member of the Brown Space Engineering Group, and today we're talking about the Nano satellite that Tim and several other members of Brown Space Engineering program have built. Today he brought a replica, a 3D printed replica of that satellite. It's taken several years to build this, to get it together, and to have permission. But you guys are launching this with NASA coming up here soon. Before we get into all the details and everything like that, talk to me just a little bit about what this satellite is.
All right, great. So this is called EQUISat, and it's a CubeSat, 1U CubeSat, which means that it's 10 centimeters by 10 centimeters by 10 centimeters. And this is a new standard for launching low-cost small satellites. So our central goal for this satellite is to prove that space is accessible to everyone. So the way that we're doing this is we have 4 big LEDs that flash 3 times a minute. So you are actually going to be able to see this once it launches on May 9th. It's going to come out 3 days later. Every time it passes over Providence, you'll be able to see it flashing in the sky. Yeah. So
this is amazing.
So on top of that, the way that we're proving that space is accessible is it is extremely cheap. So all of the parts in this cost about $3,700. So anybody could make their own, theoretically, if they have the equipment and knowledge, for only $3,700. So all of our designs are open source, which means that anybody can find them online. And also, we are teaching kids in Providence about engineering using this. So all of the principles, how to make boards, and just generally like space and general science interest.
I mean, this is so incredible, and you pretty much got all the points you wanted to make right there in that first sentence. So good for you. Let's talk actually about the satellite itself and a little bit about Brown Space Engineering. So this is a program, it's all undergrad students, which one I think is incredible. So we're not talking about NASA engineers, NASA scientists quite yet. I mean, maybe that's the path that several of you are going to take. But over the course of about, what, 6-7 years, students, a group of rotating students, made a plan, thought this is what we want to do, and now have a finalized product and put together this Nano satellite. Talk to me about what that course has been like for this group of students to put together something and now to have finally accomplished launching a satellite.
Mm-hmm. So it's been amazing. It started 7 years ago in a class called Design of Space Systems at Brown. It's a high-level engineering class, and the main project is, or the main component of the course is a design project where you come up with a design. And the original idea for this design was that it would flash from space and be proof accessibility. That was like the point. But they thought it could be done by 4 students in 1 semester.
Oh, that's a little, well, that's how you set high standards, I
Yeah.
suppose.
7 years later, here we are. Now it's in the hands of NASA, and it's extremely satisfying to see that happen. But it is difficult because every year, new students turn over.
Yeah.
So it's really, like, the engineering is a major part of this, but also the teaching. And that funnels into like our ability to teach students in Providence. We have to teach our engineers how to make this in the first place.
So let's talk about the actual materials that are going into this, because I think what's so cool about that is that it's, you know, low cost when you think about it, because we're talking about NASA's budget is huge and sending spaceships, you know, the cost of these things are in the billions of dollars, right? When we're looking at satellites and orbits and rockets and all of this, shuttles, the costs are exorbitant. Here we are, we have a very small satellite that the engineering specs are all online that you want other people to be able to access. It's all online, less than $5,000. Let's talk a little bit about the materials.
Yeah, so the main part that you see here is the solar panels. These are all made on just normal circuit boards that we order online. They're like $10
Just get
each.
them on Amazon or something? Like,
Yeah, well, you have to make the design yourself, but once you order them, it's like there's a very standard process.
It's incredible.
Everything is consumer-grade electronics. We just use a $4 processor inside, and the thing that really makes this cheap is that we design it all ourselves. Everything is made from scratch. Everything is just consumer-grade electronics, and it's really, like, the components themselves aren't that expensive.
Wow, that's incredible. Okay, let's talk a little bit about the flashing. You said these are just LEDs, but very bright. We'll be able to see them from space when they're going overhead. What makes them last as long as they're going to be able to last? How will we be able to see them?
So they get extremely hot. So that's why it's only flashing 3 times a minute. We could leave them on continuously, but they would get up to 100 degrees Celsius. So that's a little hot for all of the other electronics we have around. So they're just normal consumer grade electronics. They're normally used in industrial capabilities. They're about this big each. So most of the LEDs you see like on your phone, that's just a tiny, tiny LED, smaller than this, behind a lens that's magnifying it. The actual light component is this big. But since it's all consumer grade electronics like everything else we do, it lasts for a long time.
My goodness. Let's talk a little bit about the launch. Yeah, you don't have to hold it the whole time. Your hands will probably get a little tired. So the cube itself is about 4 by 4 by 4, 10 centimeters by 10 centimeters. It's going up with NASA, what, May 9th? Okay, so what will this launch be part of, and what's the overall mission? So you're saying goodbye, it's going to be up there in space. What's the overall program, what's that part of?
Okay, so this is launching on ELANA, which stands for Educational Launch Initiative. This is a NASA initiative that gives people, or gives especially students at universities, even high schools, free opportunities to launch their CubeSats. So this takes advantage of the small size of the satellite. There's a very standard way that has been tested and proven to launch satellites that are that small. So this is done right now for our mission by a company called Nano. They have giant metal tubes that are about this long. It fits 6 of those, and then they have a spring at one end. So this is on the International, that contains the 6 satellites. They put it on the International Space Station, basically on the airlock, and then whenever the astronauts have time to launch it, the spring goes off and the satellites just fly out. So this is a standard convention that a lot of people are using. This is the 23rd launch just of these educational CubeSats, and each one has multiple. So NASA has used this to enable people like us to launch for free. So really all of our costs are just the components.
Oh my goodness. What do you hope to get out of this? We talked a little bit about making space more accessible, but are you hoping to get some data out of this? What else are you hoping to get?
So we are testing, our secondary mission is we are testing these lithium iron phosphate batteries. They're a little bit better than lithium ion batteries, like the standard ones that you use in your phone, because they can provide a lot more current, which means they give more power, a lot more power at one given instant. So we're testing those batteries, and it's the first time they're flying in space. So we want to gather that data and then send that back down through an antenna, and just standard ground stations are going to pick it up. Anybody will be able to pick up our transmissions and see how our satellite and our batteries are doing, and we'll be testing those so that hopefully people in the future can use them.
That's so neat. So what happens, how long can we expect for this brown nano satellite to be up there, and what happens when it's done? Will it just be up there cruising around forever, or does it have an end?
So it's launching from the International Space Station, which is about 400 kilometers above the Earth's surface, depending on just where it is in its cycle. So this is relatively low for a satellite, which means that we'll only be in space at maximum about 2 years. After those 2 years, possibly less, maybe even 1 year, the satellite will go so low in the atmosphere that it will actually burn up.
It burns up.
So you'll be probably able to see that like a shooting star almost. But all of the components have been tested so that we know that once it re-enters the atmosphere, it will burn up and won't pose any danger to anyone on the ground.
I feel like something like this wouldn't really stand a chance of coming back through the atmosphere. Yeah. Something this small. This is so incredible, so neat. You said people will be able to see it when it makes its way past Providence because of the flashing lights. Do you have estimates of when people might be able to see it if they're out and about?
Yeah, so the rocket that it's going to the ISS on is launching on May 9th. And then the astronauts have to basically manually put it out the airlock themselves. So that'll take a little bit longer. That will probably be sometime in June. But we do have a countdown on our website at EQUISat.brown.edu. And you'll be able to track our progress there. We're going to track when the launch is, and then after that, when we're going to get launched out of the airlock.
That's fantastic. So we'll make sure to put a link on our website for that, so you can follow along. If this makes you as excited as me, then you can definitely follow along. Let's talk a little bit about the other missions that you have, because like you said, you really want to make space more accessible, and then you also want to be teaching others as well. So this is just one area that the students at Brown Space Engineering have been working on. You really do a lot of outreach as well. Can you talk a little bit about that and why it's important to you?
Yeah. So that's the point of our mission, to prove that space is accessible. So so one of my friends likes to say that we're proving that space isn't just the domain of amazing astronauts and brilliant rocket scientists. Really, anybody can do it. So one of the big things, big focuses of our club is going to local schools and teaching them about STEM, so science, technology, engineering, and math. And right now we're using this design and everything we're doing to teach students. So we had a big program where we went to middle schools in the past, and we're now planning more focused emphasis on EQUISat and our other projects. Another one of our projects, or our branches really, is our high altitude balloons. So these launch about once a semester, so about once every 6 months, and they're really cheap, quick ways for us to test new concepts. So our next balloon launch is going to be testing deployable solar panels. So this satellite only has these 5 solar panels and 1 LED, but what if you need more power? You need more solar panels so that you can gather more of the power from the sun. So our balloon is going to launch a couple hundred kilometers, or no, not a couple hundred kilometers, a couple kilometers up, and make sure that we can deploy those safely in a low atmosphere environment.
I just think this is so incredible, and I think how prominent that you're doing outreach to local schools. And one of my favorite things to talk about here on GoLocal Live is STEM and STEAM within our community, and creating more access and getting kids excited about these opportunities. And what better way than to show them, hey, look, a group of college students have created something that's now going up into space, and you can see it fly overhead, right? Mm-hmm. What better way to get younger people excited about space and the opportunities that are out there than to show them what you did, right?
Yeah, definitely.
When you go out to schools and you're talking to younger people, and you talk to them about that, when you talk to them about this Nano satellite, do you feel like they get excited? Do you feel like they think it's cool, or do you think they're bored?
No, they definitely think it's cool. I think in the past it was a little bit harder because we didn't have so many finished components. Yeah. Now that we're going to have that satellite that you can track, I think next year when we go and say, look at your phone, that is where what we made is, and you can put that there too, I think that's going to be a really powerful tool. But now that we've had finished components, I brought our 3D print, but we also have a lot of other test solar panels and other just components that are on the inside. When we bring those, kids really like to see, like, wow, this is space grade. It's so small and like accessible. It really, like, you can see they really enjoy it.
That's pretty inspiring. So before we let you go, like I said before, you're a sophomore. Do you have inspirations, plans for when you graduate? What do you want to do?
No, I have no idea. I came in absolutely sure I was going to be a computer scientist and wanted to do just regular software engineering for Google, Apple, Microsoft. But working on this has really made me inspired by space. And now I think I might go into NASA. Nanoracks, who we've been working with really closely, they've been a big inspiration to me and I think a lot of the team, just because we've seen like how cool their jobs are, and getting to work with teams like us would be great.
Yeah, well, I think the opportunities for you are open. I think you have good potential ahead of you. So Jacob, thank you so much for joining us here today. This has been so fun for me to talk about, and hopefully pretty educational for you. And again, we'll provide the link to all things so you can stay updated on this very small satellite, very small but powerful satellite. So thanks again for joining us. We're going to get set up here for our next guest on GoLocal Live. Hang tight.